Hello guys, welcome to Learn 360 Degree. Already in previous classes of units and measurement, we have covered the meaning and definition of units, measurement, fundamental units, derived units, along with that, a dimensional formula construction and dimensional formula of various physical quantities we have discussed. In today's class, we are going to discuss significant figures. Before going to start, please subscribe the channel, like and share it. So this is very important for your upcoming examinations. So first see the significant figures. In measured values of physical quantity, the number of digits about the correctness of which we are sure plus the next doubtful digit are called as significant figures. So just I will take a very simple examination 3050. Here I have a digits 3050. But how many digits of this number is required for my calculation, or the digit which are useful for my calculation are called as significant figures. First we will see the rules of writing significant figures, then we will see the same example 3050, how many figures are there in this example. So, rules of finding significant figures. So, first rule is all non-zero digits are significant figures. Means all non-zero digits. See here in 3050, I have a 0. Means in this 3 and 5 are a non-zero digits, hence these are significant for me. Here I am not talking about any zeros. I am talking only about a non-zero digits. Here 3 is a significant, 5 is significant. That much means here I have one more example 4362 has a four significant digits because all these four significant digits are non-zero. Means wherever you will see a non-zero number, that is a significant digit. That is rule number 1. Next we will go to the rule 2. All zeros occurring between non-zero digits are significant. See here again I will take the same example 3050, 3050. In this, all zeros occurring between non-zero digits. Here non-zero digit is 3 and 5. And in between 3 and 5, I have this 0. Now this 0 is significant for me. Means in this 1005, four significant digits are there. But still I am not talking about this ending 0. Now I got the two rules. Non-zero numbers are significant and zeros between a non-zero numbers are also significant. Next I will go to rule 3. All zeros to the right of the last non-zero digit are non-significant. So see here in this 3050, 3 is significant according to rule 1. 5 is significant according to rule 1 and 0 is also significant according to rule 2. But see what rule 3 says about this last 0. That is all zeros to the right of the last non-zero. Last non-zero is 5. Right side of this 0 is not significant. Means this 0 is not significant, but this 0 is significant. See here 6250 has three significant figures. I will take one more example 40050. Here these two zeros are significant for me, but this 0 is not significant for me. Hence here significant figures are only 4. We will exclude this last 0. Next, we will see rule 4. In a digit less than 1, all zeros to the right of a decimal point and left of the non-zero digit are not significant. For example, see here 0.00325 has only three significant figures. Means this previous 0 and these two zeros are not required for my calculation, or I can write this in terms of powers. So these three zeros are non-significant. Hence in this 0.00325, I have only three significant figures. If I take this 0078, I have only two significant figures. If I take, sorry, 0.011, again I have only two significant figures. Let's go to the rule 5. All zeros to the right of the non-zero digit in the decimal part are significant. See, already we have seen 1030. In this zero is non-significant because this is not a decimal number. This is, see here, not a decimal number. So this ending zero or a zero after the non-zero number is not significant. But when we take the same number in terms of decimal, see here, 1030, this last zero is not significant. But in this 1.030, this last zero is significant. If we consider the decimal part of a number, or a last digit of a number or zero, that is a significant figure. In this, significant figures are 3, but in this, significant figures are 4. Again, here we have one more example, 1.4750. It has a 5 significant figures. Okay, here we have a very beautiful example, 0.0050830. In this initial zero, we call it as a leading zero. Again, these two zeros after a decimal points are also called as leading zero. And this initial zero means leading zeros are non-significant. Again, this zero is between 5 and 8, which are non-zero. And this zero, we call it as in-between zeros. And these in-between zeros are significant figures. Now, this ending zero, trailing zero is significant only in a decimal, but this trailing zero is not significant in a non-decimal number. I will take this 4007. These two zeros are significant, but in this 5030, this in between zero is significant, but this trailing zero is not significant. So in a decimal, trailing zero is significant, but in non-decimal, trailing zero is not significant. This is very useful example for our examination purpose. Next, significant figures in algebraic operation. So we will see how we have to consider these rules while doing addition, multiplication, subtraction and division. So first we will go through in addition or subtraction. Same rule is applicable in case of addition or subtraction. In addition or subtraction, the numerical values, the final result should retain the least decimal place as in the various numerical values. Suppose if I have a numbers L1, L2, L3 like this. In this I will consider 1.41 meter. In this I will take 1.411 meter. And in this I will take 1.1411 meter. While considering all these three for addition or subtraction, then we have to consider the significant figures, which is least decimal places available in all the three. Means here we have a 4 figures. Here I have a 5 figures, but the least 3 is available in L1. So the answer of this L1 plus L2 plus L3, you have to round it off to only up to 3 significant figures, because our L1 is available with the 3 significant figures. Means least decimal place you have to consider. I will take one more example. See here, if L1 is 4.326 meter, L2 is 1.50 meter. See here we have a 4 significant figures. Here we have a 3 significant figures. Now we have to consider the least. Means our answer L1 plus L2 or L1 minus L2 should remain with only 3 significant figures. Then L1 plus L2 is, we got answer 5.826 meter. But this is with 4 significant figures. Now L2 has measured up to 2 decimal places. So L1, L2 is rounded off to 5.826 is rounded off to 5.83. Why this is 3? Because 6 is more than 5. So 2 is converted to 3. So round off number is 5.83 meter. This is a rule about addition or subtraction. Then we will go to multiplication or division. In multiplication or division of a numerical values, the final result should retain the least significant figure as a various numerical values. Again, same principle applies here also. If L is 12.5 meter, breadth B is 4.125 meter, then multiplication of these two will give 51.5625 meter. You can do yourself. As L has a three significant figures, and B has a four significant figures. B has a four significant figures. The least is 3. Hence, my answer of area should be with three significant figures. Again, 51.5625 is rounded off to 51.6. Why it is like this? See here, have to round off this number to three digits. So 6 is more than 5. Hence, this previous 5 is converted to next higher number, that is 6. Hence, the answer is 51.6 meter square. So this is about addition, subtraction, multiplication and division. Then I used one more word, that is rounding of the digits, means rounding of the answer. Here we have some rules. If the digit is to be dropped less than 5, then the preceding digit is left unchanged. In this 1.54, the round of number is 1.5 because we have original number 1.54 and round of number is 1.5 because the next digit of 5 is 4 and that number is less than 5. If this 4 is less than 5, then this number is remains unchanged as 1.5. See here in this 1.33, then 3 is less than 5, so this will become as 1.3. Here if we go here, if 1.71, this 1 is less than 5, so it will become 1.7. Again, we have a rule 2. If digits dropped is greater than 5, then the preceding digit is raised by 1. In this 2.49, the digit after 9 is more than 5. Hence, this 4 is converted to next higher digit, that is 2.5. I will take one more example, 1.76. Here, 1 point, this 7 is converted to 8 because this next digit is more than 5. Our rounding off is depends upon whether it is less than 5 or more than 5. I will take one more example. 1.89 is rounded off to 1.9 because 9 is greater than 5 and next digit of 8 is 9. I will take one more example. 1.36. Now this the round off of this number is 6 is greater than 5, so it will goes to 1.4. Next, we have a rule 3. If the digit to be dropped is 5 followed by the digit other than, means if I took the example 3.65 here, means this 5 is not less than 5, not greater than 5. This is equal to 5. In that case also, you have to write, I will take this as 5 because I have a one more rule. There I will discuss about 6. So this 5 will become 6 because this is equal to 5. Means if it is equal to 5 or greater than 5, then it will go to the next higher digit. I will take one more example, 3.35. Here 3.35 will rounded off to, as it is equal to 5, this 3 will become 4. I will not take here 3.65 and 3.85 example here because these two examples are in rule 4. If the digit is to be dropped is 5, see it carefully, 5 are followed by zeros, then preceding digit is raised by 1 if it is odd and left unchanged. See in this case, here it is 3.750 and one more number 4.650. This 0 we can able to drop it of course, but this 3.75 will become 3 point, this 5 is there, so 7 will become 8, 3.8. But here also 5 is present and is equal to 5, but here 6 will not change to the 7. It will remain as it is 4.6 because that is based upon whether it is odd or even. See here in 4.60, sorry, 4.65, this 5 is this 5 is equal to 5 means if it is greater than 5 or equal to 5, then previous digit is raised by 1, but in this case this previous digit is even number, so it will remain unchanged. In case of 4.75, the previous of this 5 is 7, which is an odd number. In that case it will rounded off to 4.8. This is very important rule of rounding off. In this class, we covered significant figures, rules of finding significant figures, and addition and multiplication, subtraction, all the algebraic operation we seen in this case. Here, we learned about the zeros and which are considered to be a significant figures with example. So I think this is very useful part of units and measurement while doing your examinations. Thank you so much guys for watching this. Please subscribe the channel for more videos like this.